This is Lab 1, dealing with charged tapes. Brief table of contents here. We'll have an introduction, some key assumptions, some physics principles we used in the lab, the procedure for the experiment, the coding with the GlowScript model. Then we'll explore some calculations and results, and then a what-if scenario, and then finally the conclusion. So to start with the introduction, the purpose of this lab was to understand the concept of electric fields and forces while observing charged pieces of Scotch tape and their visual attraction to forces. Some goals were to calculate the charge of a piece of tape by balancing the electric and gravitational forces acting on it, and to determine the ratio of deficient electrons to the number of atoms in a piece of tape. And just a brief explanation of some of the results found: the tape had a positive charge and repels itself, causing the tape to float above itself. The tape was attracted to neutral objects, including the desk in my hand, and the tape was attracted to a negatively charged pen, which also makes the tape have a positive charge. And then some key assumptions. You have to treat the tape as single point charges. The tapes have equal charges. The mass of the top piece of tape is not known, and air resistance is ignored. Some physics principles and concepts we used in this lab. Like charges repel, opposites attract. Charge occurs with an excess or absence of electrons. Charge cannot be created or destroyed, meaning it has to be transferred between objects. And in order for the top piece of tape to float, the force from the electric field of the bottom piece must equal the force of gravity acting on the top piece. And then some specific concepts followed. We had Newton's second law. We used Coulomb's law, which you see the equation for force due to electric field, which is E over the constant, which is 9 times 10 to the 9th over times Q over R squared. And then the force generated by an electric field, which is Q times E, Q being the charge from an observation location, E being the charge of the electric field. And of course, the units for Coulomb's law is newtons per coulomb. And then for the force, it's newtons. Next, we'll move into some of the procedures from the experiment. We saw the initial conditions. Each piece of tape with the length of 20 centimeters or 0.2 meters, and the mass of each piece of tape was 0.0002 kilograms, and the distance between the floating pieces of tape was 0.0175 meters. And for the first experiment with the U-tape, we laid 2 pieces of tape on top of each other, quickly removing the top piece to create a charged U-tape. We observed the U-tape interactions with a neutral object, a second U-tape, and a negative pen, so 3 total interactions. And as kind of stated in the introduction, the tape was attracted to the pen and to the neutral object while repelling the other piece, making the tape positively charged. Next, we move into the hanging U-tape, where we hung a charged U-tape between 2 books, holding an additional charged tape underneath until the top tape began to rise. From there, we calculated the force of gravity on the U-tape and set this force equal to the force due to the electric charge to solve for the charge of the tape. And we see the coding in GlowScript. You can kind of see how I split it up. First, we have the constants used. Some of the things that before, the distance between the 2 pieces of tape, the gravitational constant, other constants there. And then we move into the initial values we saw with the mass of the tape. And then we also had calculations for forces and for the plotting. As you see, we have the calculation for force due to the electric field and the gravitational force. And then we also move into the electric field vector. And then from there, we finished with calculating the electron deficiency, which was calculated using the width and length of the tape to get the total atoms, and then from there, get the... Next, we move into some of our results. As you see, the model generated, we had an upwards pointing electric force, the orange arrow, and an equal and opposite downwards pointing gravitational force. As seen with the values here, we had 1.962 times 10 to the negative third newtons, and the negative of that was the gravitational force. We calculated the electronic field vector, which was 2.40122 times 10 to the 5th, 0 newtons per coulomb. And then the charge of the tape turned out to be 8.17083 times 10 to the negative 9th coulombs. And then from there, we calculated the electron deficiency ratio, which was 5.43273 times 10 to the negative 8th to 1. Moving into the what-if scenario, what if electrons had positive charge and protons a negative charge? Both tape pieces would be negatively charged in this case. The tape would still be attracted to neutral items due to this concept of induced dipoles. and the hanging piece would still float as the tape pieces would still repel one another as like charges repel. Conclusion, interacting with the tape as little as possible is vital in order for the tape to maintain its charge, as touching it could transfer electrons from your hand and reduce its positive charge, as this charge is relatively easy to transfer. And the force created from electric fields can push away or pull other objects depending on the charges present, as seen with opposites attracting and like charges repelling.